All right, guys, we're on Unit 5, Day 2. And we're talking about rational or fractional exponents going into a radical form. You can also go from radical form to fractional exponents. And so we're going to be able to practice going both ways. All right. There's a few things we have to understand, but we're going to use our calculator in the very first part. So take your calculator and take 49 and raise it to the the 1/2 power, right? Older calculators, you're going to have to make sure that your 1 divided by 2 is in parentheses. Newer calculators, where you use the caret key and you can show that the 1 divided by 2 is going up with that the whole 1 divided by 2 is up in the air as the exponent, you don't need to use parentheses. Okay, so there's a couple people with the older calculator. All right. Or you can just use parentheses just in case. All right. But when you type in 49 and you use your caret key, the older calculators are going to have 1 divided by 2 grouped in parentheses. Okay. The newer calculators will show that when you use your caret key, it doesn't put a caret on your screen. It just gives you that little dotted box where when you put 1 divided by 2, you can see that the whole 1 divided by 2 is an exponent. In that case, you need the parentheses, all right? But if you're ever unsure, you can always use them. In fact, every time I enter fractions into my calculator, no matter if they're an exponent or not, I always use parentheses, okay? And when you hit enter, you're going to end up with an answer of 7. Okay. When you do the next one, 121 raised to the 1/2 power, you can make a little prediction, but it's actually going to give you 11. Okay. 8 raised to the 1/3, you might not know this one. Okay. But 8 raised to the 1/3 is actually going to give you a 2. And 125 raised to the 1/3 power is going to give you 5. All right, so the next question says, what's an equivalent expression that could be used to evaluate the problems from up above? And hopefully you guys know that using a 49 and getting out a 7, that if you took the square root of 49, that would also give you a 7, wouldn't it? And so 49 raised to the 1/2 is the same thing as a square root of 49. And I'm going to show you something that might baffle you because you probably didn't know it, okay? But the reason why that this symbol is called a square root is that squaring, when you square something, you raise it to the second power, right? Well, it's called a square root because there's technically an invisible little 2 right there. Mathematicians are very lazy in that if they don't have to write something because it's called a square root, they already know that there's a 2 involved, and so they won't write it. So they make it very tricky to learn math. All right. Also, I don't know if you guys know that, but 49 to the first power is 49. And so they don't write that little 1 exponent either, but that's actually where that 1/2 is. The 2 on the bottom is actually in the little crack of the radical, and the 1 is actually on the number itself. All right, and that's going to play an important role when it's not a 1 and it's not a 2. Okay, so again, 121 raised to the 1/2 is actually the same thing as the square root of 121. Okay, where the 2 in the little fraction there is actually right here, but you don't see it. Okay, and the 1 on top of that little fractional exponent is actually right there. All right, and then the square root of 121 is also 11. Okay, so what happens with the next one then? Well, instead of a 2 in the little crack of the radical, okay, there's actually going to be a 3. All right. And so 8 raised to the 1/3 is the same thing as, now that's a square root right now. Okay. I'm going to put the 8 underneath it, but it's not a square root because there's going to be a 3 in the crack because there's a 3 on the bottom of that fractional exponent. Okay. So hopefully you're getting that the number on the bottom of the fractional exponent actually ends up being the number in the crack of the radical. I can no longer call it a square root in this case because the number in the crack is not a 2. Okay. And then the 1 would go here. And now you can see where the 1/3 power actually is. Okay. And the cube root of 8 is actually 2. Okay. And you have a cube root button underneath your math menu. So if you guys take your calculator, turn it on, and you go to math, okay, there's a cube root button, guys. It's number 4. So make sure you find it so you know where it is. All right. So we'll go to math, go to number 4. Okay, it gives you a little cube root, and then you could type in 8 and hit enter, and you're going to see that the answer is still 2. Okay, so 8 raised to the 1/3 is the same thing as the cube root of 8 to the first power. All right, and same thing with the last one. Okay. We're going to go ahead and draw a radical. I can't call it a square root. Right now it is, okay, because there's no number visible in the crack, which we would take it as a 2. Okay. But we're going to actually put a 3 in there. And so now it's a cube root, not a square root. Okay? And that little 1 on top is actually right here. Okay? And if you try your math button again, so go back to math, go back to number 4 to get the cube root and type in 125. Hit enter, and you're going to find out that the cube root of 125 is equal to 5, the same thing as we got before. All right? So something you didn't know. All right, so then the following we're going to practice. It says write an equivalent expression for the problems below. All right, no problem. Okay, so x raised to the 1/2 power is going to be the same thing as a radical with an x underneath it, a 2 in the crack, and a 1 on the x. Okay? However, neither the 2 nor the 1 need to be written. And so if you wrote square root of x, these are exactly the same. It's just preference on if you want to see the 2 in the crack of the radical and the 1 exponent. But a 1 exponent never needs to be shown, and a 2 in the crack of a radical, if there's no number in the crack, we take it as a square root, which is exactly what that is when there is a 2 in the little crack there. All right? Okay, so that'll take some time getting used to. All right, so then the next one, we're going to go ahead and draw a radical. We're going to put x underneath it. We're going to put 3 in the crack, and then we could put the 1 here. Okay? However, of those things, we don't need the 1. So if you just wrote an x underneath, a 3 in the little crack there of the radical, you don't have to write the 1. All right, so these mean exactly the same thing. All right, next one, we're going to go ahead and draw a radical. We'll put x underneath it. We'll put the 3 in the crack, and we'll put the 7 over here. Okay, and some of you might be saying, how do you know that the 3 goes in the crack and not the 7? All right, so again, the rule, and there's a little saying that I have, and it's a little funny. So it's funny that I'm saying it on my video. All right, but what's on the bottom and when I say bottom, I'm talking about the fraction. Okay, so what's on the bottom or what's in the denominator, what's on the bottom goes in the crack. And you might get it already, but your bottom has a crack. So hopefully that will remind you that what's on the bottom goes in the crack. Always, 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 always. Okay. So with that in mind, let's take a look at the last one. So we're going to put a radical. We'll put x underneath. What number goes in the crack? Oh, the number on the bottom, because your bottom has a crack. All right, so we put the 5 there and the 4 here. And sometimes we just come up with goofy ways of remembering things, and they stick and they help us, and we get more problems correct based on a little goofy saying or whatever it might be. So if it helps you remember, then awesome. Okay, if not, you're going to have to come up with your own way of remembering. Okay. Next part, guys, it says rational or fractional exponent form to radical form. And this is what we were just talking about, but they're just kind of using some generic fractional exponent up there. So again, the radical, the x goes underneath, the n is on the bottom, so the n goes in the crack because your bottom has a crack. And then the a would go here. Okay, and that's going to actually be the same thing as if you grouped with parentheses. Okay. With that there and this there. That's exactly the same thing. All right, so just know that you can do this first, okay? Or you could do this first. All right. Then we're going to talk about one more thing, and we talked about it the other day on day 1 with a negative exponent. And hopefully you remember that the negative exponent will force that to go, the base to go downstairs and make the exponent positive. So this could be rewritten as 1 over x raised to the a over n. Okay, notice my a over n became a positive fraction, and it did that because it went on the bottom or in the denominator, and the 1 on top held it down. Okay, and then we're going to keep the 1 over. Okay. But the n is on the bottom of the fractional exponent, and so it goes in the crack, and then the a is on top, so it goes on the base. All right. All right, so we're going to go ahead and practice a couple of those. And these are some exam questions that we've seen before. Not you, but we have as math teachers. They've been on past exams. And number one says, explain how 81 to the 3/4 can be evaluated using properties of rational exponents to result in an integer answer. An integer is a positive or negative whole number. Okay. And so what we're going to do, explain means that we have to write words. Okay. So this is going to be a little lengthy, but we're going to go ahead and rewrite the fractional exponent. And that's what we're going to go ahead and write in our explanation. Rewrite the fractional exponent using a radical. Okay, and so what that's going to look like is we're going to go ahead and take a radical. Okay. Actually, we'll do this in a different color because it's not part of my explanation, but it's just showing you what I mean by explaining. So we're going to put 81 underneath. The 4 is on the bottom, so the 4 gets the crack, and the 3 goes on the 81. Okay. All right. So then we're going to go ahead and write our next direction. All right. So we could do one of two things here. We could take the 4th root of 81 if we knew it, or we could take 81 and raise it to the 3rd power. Okay. 81 to the 3rd power is going to make your number really big, and then you're going to have to take the 4th root of a really big number. All right. So it's actually going to be easier to take the 4th root of 81. It'll make your number smaller. All right. So we're going to go ahead and say take the 4th root of 81. Okay, and we can use our calculator to figure out, but basically we're trying to group this part of it. All right, so we're going to do the 4th root of 81, and then whatever we get, we'll raise to the 3rd power. All right, so take your calculator. We haven't talked about the 4th root button yet, and that's the reason there isn't one. So what you're going to do is we are going to go and type in the number 4 first into our calculator home screen. Okay. Then you're going to go to math. And then we're going to go to number 5. And you guys can see in number 5, there's a little X outside of the radical. And what's going to happen is when we press that button, the 4 in the newer calculators will go replace that X. In the older calculators, it'll look a little bit funny. It'll look like there's a big coefficient 4. And then that X will stay there, but your calculator will read that X as your 4 that you typed in. All right. The newer calculators, the notation on the screen is a little bit clearer. All right, so we're going to take the 4th root, and then we're going to type 81 now underneath the radical, and out pops a 3. Okay, and so we're going to get 3, but that cube is still there. All right, so now we have 3 to the 3rd. Okay? And so our 3rd step will be to cube 3, or raise 3 to the 3rd power. Either one does not matter. Okay? And 3 to the 3rd power really means 3 times 3 times 3, which is 27. And 27 is an integer, and that is our answer. And we have an explanation written out in words, and that's how we did it. Okay, so we're going to try another one. It's a number 2. Okay. Number 2 says, explain what a rational exponent such as 3/5 means. Use this explanation to evaluate negative 32 raised to the 3/5. Okay. So in our first step, we're going to go ahead and say that an exponent of 3/5 means the 5th root of a number, which our number is negative 32, okay, of a number cubed. Okay, and you're going to go ahead and see that. So when I rewrite this, I'm going to write it as a radical. I'm going to go ahead and put negative 32 underneath there. 5 is on the bottom of the fractional exponent, so what's on the bottom goes in the crack, because your bottom has a crack. Okay, and then raised to the 3rd power. Okay, and so that's the 5th root of a number, which is negative 32, cubed, because it's raised to the 3rd power. Right? And then we're going to go ahead and evaluate it. And again, we could do negative 32 cubed, but that's going to be a really big number that we're going to then have to take the 5th root. Okay? We could do it that way if we wanted to. But like in the last one, I think it's easier to take the 5th root of negative 32 first. Okay? So we're going to go to our calculator and make sure that you're doing this. so that you know how to do it if you have to do it on your own. Both. We're going to go ahead and type in 5 in our home screen first. Once you have 5 in the home screen, we're going to go back to math. We're going to go to that general root button, which is number 5. Your calculator, if you have a newer one, will then replace the little X in the symbol with the 5 that you typed in your home screen. And underneath it, we're going to type in -32, and we're going to hit enter. And that's going to give us a -2. Okay? Because it's a negative number, parentheses are super important at this point. Okay? Make sure that that negative number is grouped, and then that third power or the cube has to still be there. Okay? -2 raised to the third power, you can do it in your calculator. Just make sure you use parentheses around your negative number. Okay? Or you can think -2 times -2 times -2. Okay? And it's going to come out to be -8. And there's our answer. Okay, so we have an explanation in words, okay, and then we have our evaluation of what they asked us to evaluate. All right, so I will see you guys on the back side of notes.